Hey guys, it's Raz. All right, so we're going to talk about mining today because up until now, we've kind of been looking at plate tectonics and how the rock cycle influences our soil quality. It also influences our mineral resources and where we find them. It's kind of like the culmination of all of that. So before we start, it's important to note that mineral resources are not distributed evenly, right? It's highly dependent, again, on a lot of the plate tectonics and the rock cycle. And we see different minerals prevalent in different areas. I'll get back to that later. We're going to go through a lot of this in class. Just know that we use our mineral resources for like so many different things, right? From toothpaste to making food taste good, to making like art supplies, to making jewelry and dinnerware, to making a lot of our electronics, right? Again, I can keep going. There's so much of it. And all of those minerals that we use for those are found in what we call ore. So ore is like the raw material for minerals. It's what we pull out of the ground that we can then process and extract minerals out of to sell. The things with ore is that obviously they're localized. We're going to see different amounts in different areas. And we rarely know how valuable or the quality of that resource until we pull it out of the ground. So, and at that point, we've already done the mining, right? Minerals are considered a non-renewable resource because they are very slow to make and we're using them quite a bit. And in order to get them, we have to mine them in some way, shape, or form, which we're going to talk lots of different types. This says we'll save it for tomorrow, but I don't know when you're doing this, so you'll see. I'm going to skip this too. All right, so let's talk about just some of the words. I already mentioned ore, right? So we know that ore is like the concentrated minerals, the raw material that we pull out of the ground. We also mine metals. So metals are going to be things that conduct electricity, heat. We build with them. They're also found within ores, right? So even metals, we take out the ore first and then we have to process it. Okay. Reserves are the known amount of a resource left that can be mined. So usually we measure reserves in like years of extraction. So even with like oil and fossil fuels and things like that, you're going to hear we have this many years left. That's the reserve that we have of it. When we're talking about mining too, we also are going to talk about overburden. So when we have to get to a mine, we are going to need to move soil, vegetation, rocks. We remove them, right? You can see that in this picture. That's called overburden. And then after we mine, we have things like tailings and slag that are the waste materials that are left over after we've taken out the valuable stuff. And a lot of times this gets stored on mine sites in ponds. And we'll talk a little more about this when we talk about reclamation. So there's a couple different types of mining. Two general major categories are surface and subsurface. There's a couple different types with each of these. So when we mine things that are on the surface, right, these are things that are not very deep, that we don't have to like dig shafts to get down to. The first thing we have to do is remove the overburden. So we get rid of the living stuff and the dirt and the rocks, right? And we have a couple different types. We have open pit. You can see that in like that picture right there, which pretty much we kind of just dig down. Strip mining. I'll get to this in a little bit, but you basically just kind of strip off the surface and you're able to get to what you need. And mountaintop removal is just like what it sounds like. We literally blast off the top of a mountain, clear off, blast it to get to what we need there. And then you have placer mining, which is like in the little river. That's like what you think of when you think of like old timey like gold miners, right? That's placer, like where you're sifting things out and you're literally picking the pieces. Okay. Mountaintop removal out of all of these is probably the most damaging to things nearby, to the landscape, to the habitats, to the streams. But for all of these, except for maybe placer, but for all of the other ones, you're removing the vegetation and you're removing the soil. What you end up with because of that is a lot more erosion of the topsoil. So we're losing the dirt that's there. I have to stop calling it dirt. People are going to get mad at me. We lose the soil that's there. You have habitat loss, obviously, because we're taking out all of the living, the habitat that's there. And you have increased stream turbidity. What that means is the streams are cloudier because you have a lot more runoff into them. You also have an increase in particulate matter. That's what PM stands for, not afternoon. An increase in particulate matter in the air because, again, you're, blasting stuff. Okay. One of the things we're finding, right, is that this is typically what we've done. A lot of what we've done has been surface mining because the things we've need have been relatively close. The more we mine, the more we use up those easy to get to things, and we have to move more to subsurface mining, which is like actually digging down and getting into some deeper layers of ore. It's a lot more dangerous. It's a lot more expensive. So we'll talk a little bit about that. So subsurface mining, like I said, we have a lot of people that are going down to some pretty dangerous areas. So not only is it expensive to actually do the excavation, but the workers themselves, because we actually have like OSHA stuff now, and it's not as bad as it used to be. We have to have insurance and pay for a lot of the healthcare for those workers. A lot of the risks that they face when they go down there are poor ventilation. They're going down in the shaft into rock, right? Sometimes there's toxic gas exposure. There's particulate matters like lung cancer, asbestos, those kind of things. We run the risk of collapse at any point in time, or even partial collapse where there can be injuries. And then fires and explosions are another thing. So how they do this is they first will drill a vertical shaft, so like straight down to where they need to go. They elevate the people down, and then they're able to kind of work their way out. So this is how coal mining works. Like coal mining is pretty much always done this way. And again, it's becoming more and more popular to do it this way because we have to. Okay. So out of all of these, one of the biggest risks that we look at is something called acid mine drainage. So when obviously we, move these things, it rains. Even old abandoned tunnels, the rainwater gets into them, right? So whether it's active or not, when the water mixes with pyrite, which is found in a lot of the rocks that we see, it actually forms sulfuric acid. This is why we have a lot of acidic like ponds and lakes and stuff near these, because that gets into that water, and it can also infiltrate the groundwater. It lowers the pH of that water. It's an acid, right? So toxic metals are actually more soluble in those. So things like mercury and aluminum become way more soluble in that water. That can lead to aquatic life getting poisoned by it. We also have, especially from coal mining, a release of methane. Now, we talked about before that methane is an even more potent greenhouse gas than, carbon dioxide, which we typically focus on. It gets, it's just a byproduct of mining the coal. It gets vented out of the mine. Now, obviously, that's a climate change concern, right? Not only are we harvesting a fossil fuel that's going to contribute to climate change, but we're also having this release of methane, which is also going to contribute. So not bueno. And then we also have a big risk of explosion. And sometimes this continues to leak out even after the mines are closed and without regulation. Like that can be pretty dangerous. It's pretty flammable. Okay. And the other piece here is the particulate matter. Lots of soot, lots of grossness that gets into the air, definitely irritates human and animal lungs. And, we hear of like the black lung and those kind of things that are common among coal miners. But don't forget too, there's an animal part of this as well. So human and animal impacts. Okay. We also, like I mentioned, we see topsoil erosion. That's a big one. Habitat loss, I already mentioned these, and increased stream turbidity. Now, this is something I sort of pulled directly out of your book, this little graph. So it's kind of old. I would imagine that the reserves have changed. But I specifically wanted to point out that nickel, cobalt, and manganese, those three metals are something that we mine. You can see that the global reserves are fairly low-ish on those, and we have none in the United States. But those are hugely important for our technology and for our battery technologies. So as we start to think more about switching to renewable energies, a lot of the technology for the renewables, it's there. But we're working on the battery technology to be able to store that. And one of the things you hear quite a bit is about those metals. The disposal is one thing, but the harvesting is another. And a lot of times those minerals come from regions of the world where they're considered conflict minerals. The Democratic Republic of the Congo is kind of one of the classic examples used for this. People are being forced to mine. It's like basically slave labor. And people are getting really, really rich off of these at the expense of the people that are mining them. But we use them all the time. Like what you're watching this on right now uses those metals. So it's something that we have to sort of address. I'll probably show you guys this video in class. Wait, I don't want it to play. Okay. All right, last part. We can try to fly through this. When we do your cookie mining lab, this is one of the things you're going to start to think about. So after we're done with a mine, we have laws that say that we have to reclaim that mine. So Mine reclamation is the process of restoring the land to its original state. We've got to fill in the hole. We've got to restore the original contours, like so it has to kind of look like the mountain or the whatever it once was. We've got to put topsoil back, and we've got to remove all the acids, metals, and tailings. Also have to replant the native plants. They have to be native to restore the community to as close as we can get it to possible, or to original state as possible. Now, easier said than done in a lot of cases, because that's really expensive and we do the best we can, but we'll talk about some of the pitfalls of that in class. But there are rules about it. We do have to do it. All right. I apparently didn't put your FRQ in here. I apologize. I'm going to go back and fix it. So if you look at the slides, it will be. But you've got an FRQ to write on these. So why don't you stop this, go write your FRQ, and we will talk later.